let's first take these clauses down separately, because then it's easy to solve the sum. So the first clause is POQ. So the second clause is so what we do is we separate our clauses from the conjunction. Okay, now let's choose a variable. Let's say we chose P. So in the left branch, the normal practice is to use false values in the left branches and true values in the right branches. So the branches which come towards the left will have false values. So I'll say P is equal to false at decision level 1. So if P is false, then who are the clauses which will automatically become true? This clause will be true because here P becomes true. Sorry, negation P becomes true. This will also become true. This is also true. Okay, so now I have only two clauses left to check the truth value. So I will go ahead and choose the variable which will make an impact to these two clauses to decide their truth values. So that variable is Q. So I'll choose Q, and I'm going to say Q is false at decision level 2. Now I'm at decision level 2 because initially I decided the value for P and I said P is true, sorry, P is false, and that resulted in 3 clauses becoming true and 2 clauses becoming uncertain. So to decide the truth value of these two uncertain clauses, we have to choose a value for the other variable. In that case, I move into decision level 2 because now I'm looking at two other clauses, not the same clauses, but two other clauses. Now, say for an example, I chose P to be true. In that case, these clauses will not become true automatically because here negation P is false. So I have to check the values of these, Q and R. So in that case, I'm not going to jump into a separate decision level to check the value of Q and R because now say I have P, so I said P is true at decision level 1. When I say that, to check the truth values of these two variables, I'm not going to go into a new decision level because they are in the same clause. I'm still determining the truth value of the same clause. Because of that, I'm not going to go into new decision level. But if I'm going into determining the truth value of a new clause, then I'm going into a new decision level. I hope that is clear. Okay, so we have Q equals false. So if Q is false, then this will become true. However, this will become false, unsatisfiable. That is a conflict. A conflict means when we assign a truth value to a variable, one clause gives true while the other clause gives false. If an assignment makes one clause true while making the other clause false, that is a conflict, which means we have to backtrack to the immediately above decision level and choose the other variation of the truth value, which means we are going to backtrack and choose Q is true at 2. Okay, if Q is true, what will happen is this will be true, but this will be false. Again, we have a conflict. Because that assignment also made one clause true while making the other clause false. So that's a conflict. Now, we have to again backtrack But backtracking to this decision level makes no sense because we have no other variations to check in this decision level, because these are Boolean, because this is because these are Boolean values. We have either true or false. So if we have checked all those, so if we have checked both, so if we have checked the answers for both these variations, then we have nothing else to check in that decision level. So what we do is we backtrack to the immediate, so what we do is we backtrack to the decision level above it. And then we choose the other variation of that decision level, which is P is true. P is true at 1. Okay, now we have new values. So let's erase the old values. If P is true, then these two will be true, while the rest of the three are false. Not false. Uh, we have uncertainty. We have an uncertainty with regards to the other three. So now let's choose Q. We could use R as well. I'll just use Q. And I'll make Q to be false. Q is false at 2. So as you see, left hand side branches are false values while right hand side branches are true values. So if Q is false, then this will be true because Q is false means it is true. And then this becomes false, meaning again we have a conflict. When we assign Q to be false, this became true while this became false. So we have a conflict there. Then what do we do? If there's a conflict, we backtrack to the immediate above and we choose the other variation. Q is equal to true at 2. Okay, now we have Q is true. If Q is true, now let's erase these two values because now we got rid of the false values for Q and we are assigning true to Q. So the values which we have already put here with respect to the false value of Q should be erased because now we are going ahead with another set of values. Q is true now. So if Q is true, this clause is true, and to check the truth value of the remaining two clauses, we have to check the truth value of R, because if Q is true, this becomes false. So we have an uncertainty in that clause. To clear that uncertainty, we have to check the value of R. So let's choose R. So when we choose R, we have two variations again. Let's say R is equal to false. If R is false, this will be true while this will be false. So there's a conflict again. So we backtrack and use the other variation, R is true. If R is true, then this will be true while this becomes false. So that is a conflict again. So as you see, we drew the entire tree, the entire graph, and we have conflicts as results of each branch, which means this expression is unsatisfiable. There's no model, there's no assignment of truth values to the variables PQR, which makes this expression satisfiable. So this is an unsatisfiable expression. This can actually be checked by drawing the truth table for this. So if we draw the truth table for each of these clauses and get the conjunction of those two of those 5 clauses, then we will get 0 as the answer. We'll get a set of zeros in the final column of the truth table, which means it is unsatisfiable. There's no model of truth value assignment in this expression which will make it satisfiable. So, if we draw the truth table, say we have PQR, and then we have POQ, PO negation Q, negation POQO, and then finally we have the expression. So the conjunction of the entire expression. if you try to fill this truth table, you will get 8 zeros in the final column, which means this is an unsatisfiable expression.